Welcome back to the .NET Way. You're watching episode 21 of our .NET Core interview series. Following the massive success of our Design Patterns Masterclass, today we are tackling another 20-question masterclass on an absolute must-have skill for modern developers, Dockerizing a .NET Core application. Let's welcome our senior developer Aarohi to explore Dockerfiles, volumes, and cloud-native deployment best practices. Welcome, Aarohi.
Thank you. Docker has completely changed how we deploy .NET apps, so I'm really excited for this one.
Aarohi, let's start with the basics. Why is Docker so important for .NET developers?
Docker helps developers package applications with all their dependencies into lightweight, portable units called containers. It completely eliminates the "it works on my machine" problem by ensuring consistent environments across development, testing, and production. It's the absolute foundation for microservices and CI/CD pipelines.
Before we write code, what is the exact difference between a Docker image and a Docker container?
Think of it like object-oriented programming. A Docker image is a read-only static template that contains your app and dependencies. A container is a live, running instance of that image. It has its own memory and CPU, and you can start, stop, or delete it.
So, how do we create an image? What is a Docker file?
A Dockerfile is essentially a script of instructions. It tells the Docker engine exactly how to build your image step by step. It defines the base OS, copies your C# code, restores NuGet packages, builds the app, and tells the container how to run the final .dll.
Can you show us what a real-world Dockerfile looks like for an ASP.NET Core Web API?
Absolutely. For .NET, we always use a concept called multi-stage builds. In stage 1, we use the heavy .NET SDK to compile the code. But in stage 2, we use the lightweight ASP.NET runtime image to actually run the app. We only copy the compiled .dll over. This drastically reduces the final image size because the source code and SDK are left behind.
Senior question here. How do you optimize build times in a Docker file?
You do this by leveraging Docker layer caching. Instead of copying everything at once, we copy only the .csproj file first and run .NET restore. Docker caches this layer. So if we only change a .cs file later, Docker skips the package restore step entirely, making builds incredibly fast.
In your Docker file, you used ENTRYPOINT. What is the difference between CMD and ENTRYPOINT?
Both are used to define the command that runs when the container starts. However, ENTRYPOINT configures a container that will run as an executable. It cannot be easily overridden from the command line, which is why Microsoft recommends ENTRYPOINT, .NET myapp.dll for .NET apps. CMD is easier to override and is often used to pass default arguments to the entry point.
What is a .dockerignore file and why do we need it?
It works exactly like a .gitignore file. When you run copy .dot in your Docker file, you don't want to copy your local bin and obj folders or your Git history into the Docker build context. The .dockerignore file excludes them, which prevents build errors and speeds up the build process.
Have you ever used Alpine or Chiseled base images in .NET?
Yes, by default, .NET uses a Debian-based Linux image. But if you want a highly secure, ultra-small container, you can use Ubuntu Chiseled or Alpine Linux base images. They strip out all unnecessary OS components like shell terminals and package managers, making your container incredibly small and significantly reducing the security attack surface.
Speaking of security, how do you handle container user privileges?
Historically, containers ran as the root user, which is a major security risk. Starting in .NET 8, Microsoft changed the default. The default base images now include a non-root user simply called app. Because non-root users can't use ports under 1024, the default HTTP port in .NET 8 Docker images was automatically changed from port 80 to port 8080.
Once the Docker file is ready, how do you actually build and run it?
You use the Docker CLI. Docker build creates the image and tags it with a name. Docker run starts the container. The -d runs it in the background, and the -p maps port 8080 on my local host to port 8080 inside the container.
Containers are ephemeral. If a container stops, the data is lost. How do you save data?
We use Docker volumes. Volumes are stored on the host machine but are mounted into the container. This allows containers to store and reuse persistent data, like SQL databases or application log files, even if the container is completely deleted and recreated.
What is the difference between a volume and a bind mount?
A volume is fully managed by Docker and stored in a hidden Docker directory on your host. A bind mount maps a container directory to an exact specific folder on your hard drive, like c:\myproject\logs. Bind mounts are great for local development, while volumes are best for production data.
How do you pass configuration settings, like environment names, into a container?
.NET Core natively reads environment variables. You can set them in the Dockerfile using env, or pass them at runtime using the -e flag. This overrides the app settings.json and tells the .NET app to run in production mode.
Should we pass database connection strings or passwords using that -e flag?
No, that's a bad practice, because anyone can inspect the container and see plain text environment variables. For local development, we use Docker secrets or user secrets. In production, we never put secrets in Docker. We let the container authenticate with a secure vault like Azure Key Vault or AWS Secrets Manager to retrieve connection strings at runtime.
What if your web API needs a SQL server and a Redis cache? Do you run them one by one?
No, for multi-container applications, we use Docker Compose. We write a docker-compose.yml file defining all the services. Then, with a single command, docker-compose up, Docker automatically spins up the web API, SQL server, and Redis, and attaches them to the same internal network so they can talk to each other.
How exactly do containers talk to each other in Docker Compose?
By default, Docker creates a custom bridge network for your Compose file. The beauty of this is that containers can resolve each other using their service names. So, my web API connection string doesn't need an IP address. It just points to server equals db:, and Docker's internal DNS routes it to the database container automatically.
How does Docker know if your .NET API is actually ready to receive traffic and not just booting up?
We use Docker health checks combined with the .NET health checks middleware. We add an endpoint like /health in our API. The Dockerfile instructs Docker to ping this URL every 30 seconds. If it fails, Docker marks the container as unhealthy, and orchestrators like Kubernetes know to restart it.
If your container crashes in production, how do you debug it?
First, I check the standard output using Docker logs container-id. If I need to look inside the container's file system, I use the execute command. This opens an interactive terminal inside the running container, so I can inspect files or test network connectivity.
Once your image is built, how do you share it with your production servers?
We push it to a container registry. For public images, we use Docker Hub. But for enterprise code, we push the image to a private registry like Azure Container Registry, ACR, or AWS Elastic Container Registry, ECR. Our production servers pull the image directly from there.
Final question. What is your top advice for deploying Dockerized .NET apps in production?
Always use multi-stage builds to keep images small. Never run as root. Don't hard-code secrets. And most importantly, rely on an orchestrator. Don't manage standalone Docker containers manually in production. Deploy them to Azure App Services Azure Kubernetes Service, AKS, or AWS ECS to handle scaling and auto-healing automatically.
Fantastic session, Aarohi. From basic Docker files to advanced health checks and layer caching, you just gave our viewers a complete roadmap for containerizing .NET apps. If this 20-question masterclass helped you, hit the like button, drop a comment on what you want to see next, and don't forget to subscribe to the .NET Way. In episode 22, we'll continue this journey by exploring CI/CD pipelines and deploying to Azure. Thanks for watching. See you in the next one.